Okay, so we are into week 2 with the labs, just finishing up. Hope that you guys are, starting to roll with things and feeling a little better about it in the process, feeling more confident in your responses. This week brought 2 different labs, the apparent motion lab and the Mueller-Lyer illusion. So we'll go over the apparent motion first. So with the apparent motion, we had to determine if there was, it appeared as if there was progress from one dot to the other. So question 1, what is an ISI and how does it relate to apparent motion? So ISI stands for interstimulus interval, and it's time between the offset of the first stimulus and the onset of the second stimulus. So if the 2 stimulus in question are close together in space, apparent motion is strongest if the ISI is short. The further 2 stimulus are separated, the longer the ISI needs to be in order to create that perception of motion. How is apparent motion affected when the ISI is too slow? When the ISI is too slow for the dot distance, as we just mentioned, the further the distance, the quicker that it has to be. It does not seem plausible that the first dot had moved to that location of the second dot. So how is apparent motion affected when the ISI is too fast? When the ISI is too fast for the dot distance, the timing of the 2 dots again does not make it seem plausible that that first dot has moved on to that second dot location. So name 2 things that use apparent motion that aren't discussed in the background reading. So we have billboards, we have scoreboards, we have anything that would have moving text like those electronic billboards, or if we're going old school, flip books are definitely going to be something that falls into this category, something that we all played with as a little kid. Number 5, apparent motion is dependent on factors other than ISI. Describe the various factors that would affect one's ability to perceive apparent motion. For each factor you identify, describe a situation in which it would facilitate apparent motion perception and one in which it would impair apparent motion perception. So the congruency of the 2 stimuli can either impair or facilitate the perception of motion. So if the 2 stimuli being observed are physically identical, the same color, the same physical shape, things like that, that is obviously going to facilitate the motion. So if we have, something like this bottle going onto this, that's probably not going to work. But we have this going onto this, that is going to facilitate the motion. If they're different, obviously the opposite will be there. It's not going to look like this bottle is becoming my phone. So other objects or context within the screen can also facilitate or impair the motion. So if we have something where it's looking like someone is throwing a baseball, right? That is going to then facilitate this apparent motion, something that we're used to seeing being thrown or transferring. But if we have something that is in the middle of the screen here, and we're trying to throw from here, that's going to block our view because we know that things don't typically transfer through walls unless we're dealing with ghosts, which is a totally different lab. It's not a different lab. I wish it was. Describe some of the properties and or limitations of the visual system that are consistent with the finding that apparent motion is often perceived in the same way as real motion. So as we talked about in that first lab, depending on which one you did, we know about the neural pathways and the ways that our visual field sends things to our brain. Cognition, we talk about this all the time, that our brain is really just filling in spots for us. It is not a constant movie screen that our visual field has, so our brain has to piece it together. So again, these visual system ideas are transmitted through neurons. The amount of information that these neurons can transmit is limited by their firing rate. So therefore, even real motion is not continuously sent to the higher processing components of the brain. So the visual system has motion detectors that's going to pick up objects in the visual field at various locations. And this is going to be dependent on the timing of the object being fired, just like the ISI, same thing with our real motion. Last question, using your personal data, which dot distance did you assign to the shortest? Blah, blah, blah. So this one's going to be dependent on each person. The results that you have within the lab. But one thing that you should notice, though, there's a limited amount. It's typically a linear relationship. All right, moving on to lab number 2, the Mueller-Lyer illusion. So this one is the one with the line and arrows with the wings pointed wider, either inward or outward will affect things. So what is the illusion of the Mueller-Lyer illusion demonstration? So the illusion is that when two horizontal lines of equal length are displayed with the wings of the arrow, the direction of the wings, whether inward or outward, are going to create this false perception or illusion that the lines differ in length, even though they might be the same length. What is the method of constant stimuli, and how is it different from other psychophysical methods? It's a psychophysical method that allows for the measure of an individual's perception of a physical stimulus. So it's unique from other psychophysical methods in that participants compare a constant to one that is changing. The stimulus is going to be changing. Participants are unable to actually manipulate any of the items within the stimuli that are being compared. In this demonstration, the method of constant stimuli was used to measure the effect of a particular type of illusion. What else could this method be used to measure? So this could be used to measure any sort of absolute threshold and difference thresholds where the two stimuli cannot necessarily be adapted by the person involved in it. So this could be anything from brightness, loudness, pain thresholds, pressure, size, any of those. So advanced questions. What are the independent and dependent variables in this demonstration? So again, it's important to understand the components of an independent versus dependent variable. So independent light bulb, independent, dependent, we're looking at a light bulb. If it's screwed in, independent, dependent will be light on, light off, assuming that there's power coming to it, light switch, things like that. The independent variable is the length of the comparison line without wings, and the dependent variable is the proportion of times that you, the participant, judge that the line with wings was longer than the comparison line. So experience teaches us to certain perceptual relationships among stimuli. Illusions often take advantage of these expectations. Think of an everyday situation that could partly explain the Mueller-Lyer illusion. So within our life, especially if we're walking in a city or anywhere that we are, buildings are going to have this illusion. Corners are going to have this illusion. Anytime that you are looking at two objects that appear the same size, but you know that they are not in the same plane, we already know based on experience that the object that is farther away from us, if they appear equal in size, the one farther away is the bigger object. And the discussion question, how difficult did you find this task? How accurate? I got to tell you, I have done this lab so many times, and I know what it's testing, and I know that it is an illusion, and I fall for it every time. So in regard of that, it's difficult. It's difficult to overcome what our visual neurons are telling our brain. It's difficult. But I think it's pretty good lab. So I hope you guys enjoyed it. And again, like always, let me know if you have any questions or concerns.